Hello, in this video let's get into the time constant of RL circuits, its calculation, and how the RL circuit responds to a continuous AC source. Here is a circuit with a 10-volt battery, a switch and an RL circuit. When the switch closes, the voltage over the inductor jumps from 0 to the source voltage of 10 volts. Then it decreases exponentially to 0 by a given time constant. This contrasts to the RC circuit of video 1. This is due to the fact that the current over an inductor does not jump. Thus, at the switching instant the current through the resistor is 0, and so is the voltage. Therefore, at the switching instant the full voltage appears over the inductor. Gradually the current over the resistor starts to flow, and the voltage increases proportionally over the resistor. Over the reactor, however, the voltage starts to decrease at the same rate as the current increases. At the switching instant the capacitor acts as a short circuit, the inductor however is an open connection. For the evaluation of the time constant, graphically or mathematically, the same procedures apply as previously explained for the capacitor circuit. Here a very brief recapitulation. Remember the capacitor circuit where the voltage started at 0 and increased with a given time constant. And replacing the DC battery by an AC voltage source, nearly the full AC voltage appears over the inductor provided the source has a frequency of 1 Hz. If however we decrease the inductor, for example, it is obvious that the voltage over the inductor decreases as well. Please note the phase shift of the signals. Test it yourself on www.ecsb.ch. There is a free version. The link to the browser app is attached below. Here are the formula to calculate the AC voltage over the inductor. If you want to quickly and easily build an electric circuit model and interactively play with the elements, this is the place to go. For example, you can change the phase angles of the power sources in real time and watch the resulting changes in the power flow across the grid. There is no better tool to get hands-on expertise in electric circuits. You can access the browser-based tool via link below www.ecsb.ch.